So we're going to go through these three AP-style free response questions, and before we do that, I do want to quickly talk about the issue of calculators and whether we're allowed to use a calculator or not. And essentially, anytime you have questions 4, 5, or 6, you're never allowed to use a calculator. So 4, 5, and 6, we're not allowed to. So this question is question 4, so we're not going to be using a calculator. If you have questions 1, 2, or 3, 1 or 2, we're always allowed a calculator. And question 3 is kind of, it depends on the year. So in 2011, they made a big change, and they moved question 3 from being able to use one to not being able to use one. So if you get a question, question 3, you have to look at the year. So if it was 2001, 2, 3, 4, all the way up to 2010, you're allowed a calculator. Anything 2011 and later is no calculator. So most of the time, I'll try to remind you guys whether you can use a calculator or not. So jumping into this first one, 2001 question 4, they gave us a function h. They said it's not defined at x equals 0. And then they gave us h of 4 equals negative 3. And then they gave us the derivative. So part A says find all values of x for which the graph of h has a horizontal tangent. And then determine whether h has a local maximum, a local minimum, or neither at each of these values. Be careful about that each of these values. Right? A couple of you guys on one of the test questions basically kind of didn't talk about each value. You just said there's no minimum. If you got like 3 and 8 for your critical points, you need to say x equals 3 is a maximum, x equals 3 is a minimum, or x equals 3 is neither. And then you need to justify that. So justifying is with that explanation. So now, the horizontal tangent part, that's a little bit different than a critical point. That's only when the slope is 0. So that doesn't include the undefined case. Now, this question is a little bit mean and tricky, because if we're going to determine a maximum and a minimum, we do need to consider the undefined case as well. So we're going to set h prime of x equals x squared minus 2 divided by x. We're going to set this to both 0 and undefined. But when we box our answer, we're not going to include the undefined one. But we still need to consider it, because that's going to help us with our number line. So to set this equal to 0, we're going to do x squared minus 2 equals to 0. That's the numerator. To set it to undefined, we're going to do the denominator equal to 0. This gives x squared equals 2. Take the square root of both sides. Be careful about this. We do need to include the plus or the minus. Now, if you want to box this, these are the values, or you could say, h of x has a horizontal tangent at x equals plus or minus square root of 2. Right? 0 is not a horizontal tangent. 0 is only a critical point. But it's very important to do 0, because when you make your number line, you need to have all critical points. So if we didn't include 0, we would get this question wrong. So that's why it's very important to make sure you include 0. Now we're going to plug in a test number. If you're not sure what the exact value of square root of 2 is, you can kind of take a guess. It's 1 point something, right? So, but you could plug in anything smaller. So you could even plug in like negative 10. So negative 10 squared is positive 100, minus 2 is positive 98. Divided by negative 10 is a positive divided by a negative. And that will give us an answer of, or a test point of decreasing negative. Then say negative 1. Negative 1 squared is positive 1. 1 minus 2 is negative. Oops. And then negative 1 is negative again. So negative divided by negative gives a positive. When we plug in 1, 1 squared is 1 minus 2 is negative. Divided by 1 would be positive. Then I could plug in 3, or I could plug in 5, or I could plug in 10 again. And either way, I'm going to get positive divided by positive. So, oh, this guy should have been negative. I'm sorry about that. This was a negative divided by positive. So we have decreasing, increasing, decreasing, increasing. And so with this, we can see that negative square root of 2 is a minimum value, and positive square root of 2 is a minimum value. We don't need to worry about 0, because that wasn't a horizontal tangent, so they didn't ask us about that. So this is where it really gets into making sure we read these questions very carefully, and that we kind of understand, we start to understand what the language means, and connecting that, hey, horizontal tangent is only the points where the slope was 0, right? So what we're going to say is x equals square root of 2 is a local minimum, because h prime of x switches or changes from negative to positive at x equals negative square root of 2. And then we'll do at x equals positive square root of 2. And then we'll do the same thing for negative square root of 2. Right, for negative square root of 2, it's the exact same explanation. So if you wanted to group them together, you could as well. And so for this question, essentially this was worth 4 points. You got 1 point for solving for the plus or minus square root of 2. And then this section was worth 3 points. Right, if you did it perfectly, you would have gotten 3 out of 3. They were actually pretty nice on this one, in that if you had not solved for the 0, then you would have made a mistake here, and they were still going to give you 1 or 2 out of 3 if your explanations matched the number line that you had created. So in order to get the full 3 points, though, we need the where, essentially, the what, and then the why for both of these. So that's kind of an important thing to just kind of look at and learn how to write these. Again, you could have grouped them. You could have said both x equals square root of 2 and x equals negative square root of 2 are local mins. Okay, question B. Write an equation for the tangent line to the graph of h at x equals 4. So we want to write an equation for the tangent line at x equals 4. So anytime we see, write an equation of a tangent line, I always like to start off with our x1, y1, and m. So x1 is 4, and y1 we would have to plug into the original. We don't have an original, but they told us h of 4 is equal to negative 3. So we're just going to do negative 3. And then for m is the same as h prime of 4, right? And this is x squared minus 2, so 4 squared minus 2 over x, so over 4. So this gives 16 minus 2 is 14 over 4, which we can simplify to 7 halves. So that's our m. And so our tangent line would be y minus negative 3, or y plus 3, equals 7 halves times x minus 4. And then we can just box that. This one was worth 3 points. Oh, and then, sorry, there's one more part of this. This is why we need to make sure that we're... Did I skip? Oh, yeah, I skipped a C. That's my fault. Okay, so just kind of ignore what I did there for B. This was C. Okay, so this was only worth 1 point, sorry. So this was just 1 point. You got 1 point for getting it all the way correct. I think they figured this was easy enough. Just 1 point. So again, I skipped B. B asked, on what intervals, if any, is the graph of h concave up? So we need to make sure that we're connecting the word concave up with our second derivative, right? That's the second derivative being greater than 0. Well, before we do that, we just set it equal to 0 to find our possible inflection points. So h prime of x was equal to x squared minus 2 over x. So we're going to do h double prime of x. And so that'll be low, right? Quotient rule, d high minus high, d low, all over low squared. So we need to do quotient rule for this, and we're going to set that equal to 0 and undefined. Right? That's how we find our possible inflection points. So we get 2x squared minus x squared plus 2, because we're going to distribute that negative, all divided by x squared. Again, we're setting this to 0 and undefined. So this will become 2x squared minus x squared is x squared plus 2 divided by x squared equals to 0 and undefined. So we're going to set both the numerator and the denominator to 0. So we set the numerator to 0, x squared plus 2 equals 0. We set the denominator equal to 0 for the undefined case. This gives x squared equals negative 2, and when we take the square root of a negative, we get no solution. So there are no possible inflection points where the numerator is 0. For the denominator being 0, we're going to get x equals 0 when we take the square root of it. Now, you do want to remember that this does not exist here. So it's not actually an inflection point, but it still can change concavity. Right? It's not an inflection point because it might be like a vertical asymptote. But again, it still can change concavity, so we want to kind of be careful about that. So at x equals 0, that's our test point. We're going to plug in a number smaller than 0, say like negative 1. Negative 1 squared is positive 1, plus 2 gives us a positive answer. Negative 1 squared is positive again. And then if we plug in positive 1, 1 squared plus 2 is positive, 1 squared is positive, so we get positive again. We want to make sure we label this as well, h double prime. So concave up and concave up. Now, it's not concave up for all values. It's concave up everywhere except at 0. So at 0, it's actually not concave up. So what we'd say is h of x is concave up for negative infinity to 0, union 0 to infinity. We also could have said for all real numbers except x equals 0, like we could say for all x but x equals 0 or x is not equal to 0, something like that. I'm going to choose to write it this way, though. Any of those would work. And then we're going to say because h double prime of x is greater than 0 for those intervals. Right, or you could say for x is not equal to 0. So that's our answer. And this was worth 3 points here. So we got 1 point for taking the derivative, doing this quotient rule essentially. Then we got 1 point for essentially showing that h double prime of x is greater than 0, right, kind of plugging it in somewhere. And then we got 1 point for our explanation, for our answer. So that was worth 3 points. And then part D asks, and so again, we should have done C just now. So we did C, we got this tangent line. And then part D says, does that tangent line from C lie above the graph or below the graph for x is greater than 4? So if we're going to plug in a point and try to test that point, right, like say plug in 4.1 to get an approximation, would it be above or below our actual value? And so what we need to kind of remember on this question is anytime we have concave up, this is just something we have to remember and kind of learn. Concave up, our tangent lines will always be below. So our tangent lines are below for concave up. And anytime we have concave down, our tangent lines will be above. So this, you don't need to draw this into your question. What I'm doing in blue wouldn't even go on your paper. But it's something that, we never officially took notes on, but I know we've talked about quite a few times now. And so now that we can actually go in and solve for these, right, we can go in and figure out, using our second derivative if something's concave up or concave down. Now we're going to get these questions even more. So anything above 4, right, is somewhere, here, which is second derivative is positive. It's concave up, right? So because it's concave up, it's going to fit with this first kind of section, right? So it's concave up. That means the tangent line will lie below the graph. So it's a really easy explanation or answer. We just say the tangent line will lie below the graph of h because h of x is concave up for, now I'm not going to say, the interval, I'm going to use what the question used. You always want to go back and reference the question. So for x is greater than 4. So that's what we're going to use. If you wanted to say, instead of h of x is concave up, if you wanted to say, because h double prime of x is greater than 0, for x is greater than 4, that would work as well. So either of those two would work. And this was just worth 1 point. And it was pretty straightforward, so it was just worth 1 point. So go ahead and score yourself, kind of give yourself reflect on it a little bit and think about what you could do better and, what kind of words you need to read more carefully. And then we'll move on to the second question. So this one did require a calculator. And it's something where, we have this graph here, and we may want to even graph it on our calculators. So I'm going to pull up my calculator, but it's something that, we want to go over and talk about how to graph these. So let's make this a little bit bigger. So if we hit this button, that takes us to our graph. And we can type in the graph, right? But remember, this is f prime. So we're going to type in this graph, e to the negative x over 4, sine of x squared. We'll type that in. So e to the power of negative x divided by 4. And then, you need to make sure you click the right arrow to bring yourself out of the exponent. If you don't click this right arrow, you won't come out of that exponent. And then I'm going to use times and trig sine of x squared. Okay, so we can graph this. And the graph looks pretty weird, but we can also adjust our zoom. So, if we look at this, we only are, going on the y value between 1 and negative 1 and up to 3. So, I showed us how to do this in one of the videos. We're going to go to Windows Zoom. We're going to go to Windows Settings. Now, I like to, for my x minimum, even though we're starting at 0, I like to always go, maybe 0.5 bigger than that. On the right side, we went to 3, so I'm going to go 0.5 bigger. And we went between negative 1 and positive 1. Again, I'm going to go 0.5 bigger, just so I can see it a little bit more. So again, the way I got these numbers was I just picked, on the graph that they showed us, it started at 0, so I just went to negative 0.5. We went out to 3, I just went out to 3.5, just so we can see a little bit more. And we went down to negative 1, so I went negative 1.5 and positive 1.5 for my y's. So now we get a graph that looks much more like the one that we're given. You can take this, you get the little hand. If you click and hold, then you can move it. Right, so you can click and hold with this cursor and move it. So now we have our graph, right, and that's going to help us out. So this says, use the graph of f prime to determine whether the graph of f is concave up, down, or neither between 1.7 and 1.9. Now, looking at the graph, I would think, 1.5 looks like it's about here. So I think 1.7 would be somewhere around here and 1.9 would be somewhere around here. But you never want to assume in math, so it's better to even just come in here and just use the trace button and actually find out where exactly are those points. So 1.7 is, somewhere right there, and 1.9 is right there. So in between those two sections, right in this area, are we concave up, concave down, or neither? And so what we need to remember is, what graph do we have? We have the graph of f prime. How do we connect f prime to concave down? Right, to concave up or concave down. Right, that's based on f prime is increasing, will tell us that our graph was concave up. And f prime was decreasing, tells us if we were concave down. Right, f double prime, that's going to be for the positive and negative, but we don't have f double prime, we have f prime. So this graph here, in between these 2 points, that graph is decreasing. So what we'll say is, f is concave down. On the interval, I'm just going to use their wording. 1.7 less than x, less than 1.9, because f prime of x is decreasing over that interval, or for that interval. Right, so we're always going to use one of our explanations from that table that we created in class in our notes, and it's just based on, if they used, if we have the first derivative, the second derivative, what we have, then we're going to kind of choose that explanation. But this is a perfect explanation right there. And so this question was worth 2 points, and they don't really give you like a guessing point. If you just said concave up or concave down, that's a 50-50. They're not going to give you a point without at least some sort of a reason. So, technically it's 1 point for concave down and 1 point for this answer, but if you just say concave down with no even guess at a reason, you're not going to even get a point. So at least guess at a reason. Okay, B is on the interval 0 less than x less than 3. At what values does the graph have a relative maximum? And where does it have a relative minimum? So we can kind of solve for these 2 ways, but what we need to do is we need to find our zeros, right? We're going to have maximums and minimums at our zeros. The issue is we don't know what those values are, and that's what they're asking us. So this is where we have to use our calculator and kind of learn how to do this. So there are 2 ways we can find these zeros. The first way is actually on the graph itself. So on the graph itself, we can go to Analyze Graph. We can click on 0. We can go to the left of our 0. And go to the right of our 0. We get 1.77. The issue with this number is it's only 2 decimals, okay? On the AP test, I want you to always go to 4 decimals. If you report this answer, you will actually not get points for this. You'll get this marked wrong. So that's very important. You'll get that marked wrong. So what we have to do is, I'm going to go to Menu, and I'm going to go to Settings. I'm going to change where it says float 3 means I want it to report 3 digits. I'm going to change this to at least 6, 7, 8, or even 9. I'm going to go with 9. It's going to give me a lot more decimals. And now, this point here, now I can go out safely to 4 decimals and be fine. Then I'll click on my 0 again. So Analyze Graph, 0. And this time I want this 0, the second 0, so I'm going to go to the left of it. I'll go to the right of it. And I get 2.506. Now, I don't need this third one because this is actually after 3. So if we look at our graph, right, we only had 2 zeros here. Technically, we had a third one at 0, but that can't be a maximum or a minimum because it's at an endpoint. So remember that when f prime changes from increasing to decreasing, right, increasing to decreasing, that would be a max, and decreasing to increasing, that would be a min. So in this case, if it's going positive, right, like positive slope, to negative, right, this is going to give us a max, a local max, and now we're going negative back to positive. This guy will be a local min. Right, if you wanted to make a number line just to help you out, you can. You don't have to, but you can make a number line. So we kind of said we're going between 0 and 3 for f prime. And then we have our 1.77. Like I said, 4 decimals is always safe, so 1.7724. And then 2 point, I think it's 5066. Yeah, 5066. Right, and then, so those are the values at those zeros, so we're above the axis, so positive. Then in between the two zeros, we're below, so negative. And then above is positive, so we're increasing, decreasing, increasing. If that's going to help you out to figure out if they're maximum or minimums, then that's great. So we'll say is that x equals 1.7724 is a relative maximum because f prime of x changes from positive to negative. And then we can say x equals 2.5066 is a relative minimum because f prime of x changes from negative to positive. So this question was worth 3 points, right? You got 1 point for finding the 2 points, and then you got 1 point for the answer key. Now, one thing that I didn't write here, and this is my fault, that you really, really should write, is you should absolutely write f prime of x equals 0. Sometimes you get a point just for writing that, so make sure you write that. And then I'm going to write in, that's x equals 1.7724 and 2.5066. If you're missing this, you could lose a point. So anytime we're doing relative max, relative minimum, we always want to start with that. Let's set it to 0, and let's write the answers. Now, you don't need to show any work by hand. They're expecting that you found those answers on the calculator. So I found those answers on my calculator using the graphing tool. I do want to show us really quickly, we could have also done these using the solve tool. So algebra, solve, and then what we could have done is we could have taken this same, e to the negative x divided by 4 times sine of x squared. I'm going to be lazy and just copy paste it so I don't have to retype everything. But we could have taken that same thing here and written equal to 0, comma x. Now, the issue is I get this weird n1 square root of pi thing. And that happens anytime you have a sine. So anytime you have sine, cosine, tangent, any trig, you have to remember to add in your interval. So we're going to add an interval as always after the parentheses. We put in an at. In the interval, they didn't really give us an interval in the question, but they gave it to us in question B on the interval 0 to 3. So we can just say 0 less than x less than 3. And now we're going to get square root of pi and square root of 2 pi. That's different than what we had, but it's actually the same. When you hit Control Enter to give us a decimal, those are the same answers. So if you had done it this way, you may have actually gotten square root of pi and square root of 2 pi. And so that would have been fine. So instead of putting 1.7724, if you had put in the square root of pi, that would have been okay, right? And here you could have put in square root of 2 pi. And really, we also should have at x equals 1.7724 and at 2.5066. You always want to add in that at. So again, 3 points. This one shouldn't be too hard, but it's about learning to use that calculator correctly. Okay, and then the third one is write an equation for the tangent line to the graph at x equals 2. And they gave us in the question, f of 2 was 5.623. So on C, we're going to do x1 is 2. It's important that they gave us that y1 because we don't have the equation to actually plug it in right now. So 5.623. And for m, we're just going to go ahead and plug in 2. So again, either we can do this a lot of ways. We can just type it into the calculator. I don't want the solve part. We just wanted this part. So we type this into the calculator. You could change all of your x's to just be 2's, right? We could just make them each a 2. Or we can do at, and we can do x equals 2. Right, and if I get something like that, kind of weird, Control Enter gives me this decimal. Or I could have also done it on the graph. I've already graphed this. So I could have gone to Menu, Trace, and then just typed in 2, and that'll plug in 2 for me. So I get 2 comma negative 0.4590. So negative 0.4590. Do put that 0 in, okay? Don't just drop off the 0. You want 4 decimal places. So negative 0.4590. Right? The 0 tells us that it keeps going. That it wasn't just 0.459, that it was 0 and then kept going. So y minus 5.623 equals negative 0.4590 times x minus 2. So there's the equation of our tangent line. And then it says, will the tangent line be above or below the graph of f? So this is going back to that same thing. So at negative 0.459, right, and when we traced it, we see it here, it's still decreasing here, right? It's still decreasing at this point. So because it's decreasing, that means that we're concave down. So if we're concave down, right, then any tangent that we draw is always above our line. So the tangent line will be above the graph of f because f of x is concave down at x equals 2. If you want to say because f prime of 2 is decreasing, that's how we knew it. So we always need to do the at x equals 2 because that's where we did our tangent line. So hopefully this one makes some sense. I know this was tricky. This is one of the first ones, I think this is the first one we've ever done that really required the use of a calculator. So again, go and grade yours. Think about, what you need to work on, what words you want to really focus on. Maybe go back up here and star some of the words that you need to focus on, right? Like within A, B, and C, that you just need to read a little bit more carefully and that you need to practice or make flashcards for and kind of memorize. And then we'll move on to the third question. So moving on to this final free response question. This one is a little bit trickier just because of the K, right? The K is a constant, and that can sometimes confuse students, but they tell you K is a constant, just treat it like if it was a 2. Like, pretend it's a 2. If you want to even put a 2 there and then, change it back to a K, like erase all your 2's and make them K's, that works also. So, on A, right, we're going to take the derivative, f prime of x, and again, just kind of make it K times, what's the derivative squared of x? That's one we memorized, 1 over 2 squared of x. So, that's how that works. We'll move the K up, but for now I'm going to leave it like that. And then minus the derivative ln of x is 1 over x. And this is actually a perfect answer. You get full credit. Now, if you want to, you can rewrite that as f prime of x equals K over 2 squared of x minus 1 over x. But that's fine. We can leave it like that. We don't have to combine any terms or anything like that right now. We can just leave it just like that. Okay, and then for the second derivative, we're going to take the derivative of that. So f double prime of x would be the derivative of this guy. Now, in order to take this derivative, because we're doing this by hand, I am going to rewrite my first derivative as k over 2 is a constant. I'm going to write this as x to the negative 1/2 minus 1 over x. If you want to write it, minus x to the negative first, you can as well. But I'm going to use that reverse power rule. But I did change this, square root to be to the 1/2 power and move it to x to the negative half because that's going to help me take the derivative easier. So, taking the derivative, negative half times k over 2 is going to be negative k over 4. Right, that's all just a coefficient. X to the, when I subtract 1, we're going to get negative 3/2 power. And this will be minus negative 1 over x squared. That's that reverse power rule. Right, multiply up, switch the sign, and then add on 1. So that'll become plus 1 over x squared. But if you had wanted to do it, the way where you have x to the negative first and multiply down and make like, positive 1, x to the negative second, and that's 1 over x squared, that could have worked as well. So you could have done it that way as well. So I chose to do it the reverse power rule way. I like that a lot, but either way would work. So there's my first derivative, there's my second derivative. It honestly, for free response, it doesn't really matter how you write these. Okay? If you had written this as negative k over 4 x to the negative 3/2 plus x to the negative second, you would have gotten the point. If you would have written it as negative k over 4 square root of x cubed plus 1 over x squared, you would have gotten the point, full credit. So there are lots of different ways you could have written it. Even for the first one, if you had written it as k over 2 x to the negative half minus x to the negative 1, you would have gotten the point. So, there are lots of different ways we can write it. But the two that I like are the way that I wrote it here. And so when you're grading this, they were each worth 1 point. So 1 point for the first derivative, 1 point for the second derivative. Okay. Next up, they say for what value of the constant k does f have a critical point at x equals 1? For this value, determine if whether f has a relative maximum, minimum, or neither at x equals 1. So this one is a little bit tricky because they're actually telling us that the critical point's at x equals 1. So this is a little bit different. But what we need to remember is critical point is when we take the first derivative and we set it equal to 0. That's where we get a critical point. But they're telling us that this is going to happen at x equals 1. That's going to happen. So we're going to take that k divided by 2 square root of, now instead of x, we're going to plug in a 1. Minus 1 over 1, and we're going to set that equals to 0. So that's a little bit tougher. You're going to get 1 point for doing that, for setting the derivative to 0. You're going to get 1 point. And even if you just put f prime of x equals 0, right, kind of either or right there would get you the point. Okay, next, now we're going to just go ahead and solve for k. So this becomes k over 2 minus 1 equals 0. I'm going to add 1 to both sides. Multiply both sides by 2, and we'll get k equals 2. Okay. This would have been a second point right there. Would have been solving for k. Getting 2 gets you a second point. Now we're going to go ahead and, because it asks us, is this a maximum, minimum, or neither? We're going to go in and make our number line. So we're going to have f prime. We're going to put in for 1, right? Not for k equals 2, because it's where x is our critical point, right? X equals 1 is our critical point. We were just solving for k, so now we know what the equation is. So now we know that our f prime of x, before we had written k over 2 squared of x, now we can put 2 over 2 squared of x minus 1 over x. And if you want to cancel out the 2's, you can. Just make sure you put a 1 in there. So you have 1 over square root of x minus 1 over x. So this will be our kind of f prime. Now, where we need to be careful on our number line, this is actually very careful, is let's pretend we plugged in 0. If I plug in 0, I'm going to get 1 over 0. 0 is actually also a critical point. And we kind of saw that from that. So we want to be careful about just any other critical points this might have. So this does have a critical point at 0 as well. So when I plug in, I need to plug in something in between 0 and 1. And actually, really, there is nothing on the left side of 0, because you can't have the square root of a negative, and you can't take the ln of 0, so 0 actually doesn't even really exist on this. And that's also, for x is greater than 0. So when I drew my number line like this, you would have actually been even better off if you had drawn your number line according to how they had it. So f prime, basically going from 0 out to infinity. So the key here is when we're plugging in, I'm just thinking I need to plug something in that's smaller than 1, but it's also bigger than 0. So let's try like 0.5. So if we plug in 0.5, 1 over the square root of 0.5 is positive, and minus 1 over 0.5 is also positive, but this is where we have to be a little bit careful, is which one of those was bigger, right? Because that's going to determine if I have a positive or a negative answer. And when you square root a decimal, right, what's going to happen is, this is a little bit weird, but like, and if you wanted to, you could even pick a decimal that would be easier to square root, like, if you do 0.5 squared, you could kind of undo that. But when you square root a decimal, what's going to happen is that we are going to get a smaller decimal. So this is a smaller decimal, right? And this is a little bit weird here, but sorry, I think I might have said that backwards. When we square root a decimal, we get a bigger decimal. So the square root of 0.5 is actually 0.7, right? And the reason this happens is, pick any decimal, let's say 0.2. If you do 0.2 times itself, it ends up becoming smaller, right? So like the square root of 0.04 is 0.2. So when you take the square root of a decimal, it gets bigger. It's the opposite of, when I take the square root of a whole number, of 9, it goes to 3. But when I take the square root of any decimal, and by decimal I mean a decimal smaller than 1, I should have been specific there. Let's say a 0.81, right, it gets bigger, it's 0.9. 0.9 is bigger than 0.81. So what happens is, this is getting bigger, but there's another thing at play here, is that they're in denominators. So because they're in denominators, even though this is going to be bigger, when you do 1 divided by it, it becomes smaller. And so the key here is that this ends up being negative, and this ends up being positive. Now, I know that's really kind of funky. An easier way for a lot of you guys, if you can't really think the way that I just did, would be to just try to combine the like terms, and it'll actually be a lot easier. So times square root of x, times square root of x, and now we get the square root of x. Square root of x times square root of x is x minus 1 over x. This gives us square root of x minus 1 over x, and now it's going to be a lot easier to figure out the positive and the negative deal. So if I picked something to plug in here, like say 0.5, the square root of 0.5 is still smaller than 1. So the square root of 0.5 minus 1 is going to be negative, and then the square root of 0.5 is going to be positive. So that's why we have this negative here, right? Then if I plug in, say, 2, or even 4, because 4 is easy to take the square root of. The square root of 4 is 2, 2 minus 1 is positive, over 4 is positive. So we get positive. So this is actually a lot easier to plug in and to do our number line if we combine like terms and get it into one fraction. That'll actually make it a little bit easier on us. So now we have that we are decreasing and then increasing. And so then we can say f of x has a relative minimum, because that's what they asked, was it a minimum, maximum, or neither, at x equals 1, because f prime of x changes from negative to positive at x equals 1. So this was definitely a little bit tougher to plug in, but, I think it is doable. So this was worth 2 points here. You got 1 point for stating that it was a minimum. And if you just guessed without showing any work, they're not going to give you the point. And then 1 point for this explanation. So you need to at least try to show some kind of a number line in order to justify it. Okay, now for C, C says for a certain value of k, so this is a new value of k, so we're not at k equals 2 anymore, the graph of f has a point of inflection on the x-axis. So the x-axis is, right, whenever y equals 0. And we want to find this value of x. So that's whenever y equals 0, or the original f of x equals 0. This is a very tough question, actually, for C. So on C, what we have to do is we basically know that if it's on the y-axis, or on the x-axis, meaning y equals 0, f of x equals 0. So we know we have f of x equals 0, and then we know it's an inflection point, so we know we have f double prime of x equals 0 at that same point. And so that's actually 2 equations, and we have 2 variables. We have x and we have k. So the original f of x was 0, that's going to be k, the original graph, square root of x, minus ln of x. That's what they gave us for f of x, when we set that equal to 0. Then our second derivative, right, we solved up here, negative k over 4x to the negative 3 halves. Right, I'm going to write it like this, negative k over 4x to the 3 halves. I'll write it like that. And then plus 1 over x squared equals 0. That's from f double prime of x, right? So now I have 2 equations, like, right, I have 2 k's and I have 2 x's. So I have 2 equations and I have 2 unknowns, and so now I can solve. So I'm going to isolate from one of them. To me, the easiest term to isolate looks like it's going to be this value k right there. So what I'm going to do is I'm going to isolate that. So I'm going to say k squared of x. I'm going to add ln of x to both sides. So k squared of x equals ln of x. Then I'll divide both sides by square root of x. And so that's my value for k. Now I can take my other equation, and anywhere I see a k, I can plug in ln of x over square root of x. And this was definitely a really tough question because it was a non-calculator question. If we look at this question, if we look at the year, this was 2007. Okay, this was actually, I believe this was the year that I took the AP exam. So I don't remember if this was on my exam or not, though. I took BC, so I'm not sure if this was on mine as well. It might have been. But since 2007, they've a little bit moved away from math this kind of complex by hand, and they've asked a lot more concept questions. But it is something that we still want to, try to get comfortable with, but recognize this is definitely probably one of the harder questions. On most AP exams, there's some easy questions, some medium questions, and some really hard questions. And your goal is to get all of the easy questions right, to get like, maybe half of the medium questions right, and you'll pass, even if you don't get a single hard question right. And if you can try the hard questions and get some points, then it's even better. So this would definitely, I would fall, especially this part C, into a really hard question. So something we want to practice, but don't stress out if you're like, I could never do that on my own. So I'm going to write this as ln of x over x to the 1/2 power over 4x to the 3/2 power plus 1 over x squared equals to 0. Then I'm going to multiply both sides on the left, like the top and the bottom, by x to the half. That way I can get rid of my fraction inside of a fraction. And that'll give us ln of x. And when I add 1 half plus 3 halves, that's actually 4 halves, or x squared. So ln of x over 4x squared plus 1 over x squared equals 0. So I'm going to multiply by 4 and by 4. And that'll give us ln of x plus 4 over 4x squared equals 0. Now, when we set something equal to 0, this is kind of important. When we set it equal to 0, we're actually only setting the numerator to 0. Right? The denominator to 0 would be the undefined case. We've kind of gone over that a little bit. But it's just kind of the reminder is if I had 0 over 4, that's 0. If I had 4 over 0, that's undefined. So whenever you're looking for undefined, you set the bottom to 0. When you're looking for 0, you set the top to 0. So in this case, we're going to set ln of x, the top, plus 4 to be equal to 0. That's going to give us ln of x equals negative 4. And, you know, I totally messed something up here. I just kind of caught it. And that was this negative symbol. I totally did not draw in that negative symbol. So let's just add in a negative really quickly to all these. So that should have had a negative, 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 should have had a negative. So negative ln of x equals negative 4. So we'll divide out that negative, and that'll give us ln of x equals 4. And remember, we learned that to get rid of an ln, we take e to the power of both sides. So e to the power of both sides. So this gives us x equals e to the power of 4. So that's my x value. Now, they asked us in the question, let's go back up and just make sure we answered it completely. For a certain value of k, the graph of f has a point of inflection on the x-axis. Find this value of k. So they don't want us to find x, they wanted us to find k. So we did find x, but we have to then go basically back up here, where we have k, and we can do that. So k equals the ln of e to the 4th power over the square root of e to the 4th power. And if you box this, you'll get full credit. If you want to simplify it, you can simplify because the ln and the e will cancel out. So you can get k equals 4 over the square root of e to the 4th. Don't worry about rationalizing this. I know that in Math 3 they would say you don't want to have a fraction inside of a fraction, or sorry, a radical in the denominator, so like multiply by square root of e to the 4th over square root of e to the 4th. Don't worry about it. On free response, just leave it there. If you look at an answer key, they'll actually write this as 4 over e squared. The reason it's e squared is the square root of like x to the 4th or e to the 4th is actually just e squared, right? But any of these three answers would work perfectly. Okay, and honestly, I'd probably leave it at the first answer because we don't have to do any more complicated math here. So I would just say, hey, that's a fine answer, I'm leaving it there. You get full credit for any one of those three. So as far as points go, this is worth 3 points, but this is where I want to show you guys that even if this question was hard as like heck, everyone in this class should be able to get 1 point. Because you literally got 1 point for writing either one of 4 things. Either f of x equals 0, f double prime of x equals 0, actually writing it as k squared of x minus ln of x equals 0, or writing the second derivative 0. Any of those 4, not all of them, just any single one of those 4 gave 1 point. And 1 out of 3 on this, that would be like something that actually could help you pass the exam. And I think all of us could get that because literally they said, you know, on the x-axis, you literally just write, oh, that's y equals 0. But instead of y, write f of x. Or you could see inflection point. So write f double prime of x equals 0. Literally, you just got yourself a point. Now, everything else was much harder. I totally get that. So, basically, for solving for k and plugging it in, that was worth 1 point. And for getting any one of those 3 final answers, that was worth 1 point. But, like I said, at least writing something down on these and practicing that, taking this question, at least writing something that I can know from that, and getting a point there, that's the difference between you passing with a 3 and you getting like a high 2. So, there's that. I did tell you guys that we would also go over the remaining multiple choice questions with the calculators. So, we had, let's see, we were up here. So on the interval from 0 less than x less than 10, how many relative minimums does the graph of g of x have if g prime of x is equal to sine x over x plus 2? So as soon as I see relative minimums, I want to be thinking, I want to set g prime of x equal to 0. I want to make a number line for g prime. Now, instead of doing arrows, I'm going to go from 0 to 10 because that's the interval that I was given. And so, because I'm doing minimums, I'm thinking about g prime. That's what I want to graph in my calculator. So we want to make sure to graph that in our calculator. And I'm going to go to menu, actions, and just delete whatever I had on the screen. So delete all. That'll kind of start fresh. And luckily, I'm already on the right zoom setting. I'm at between 0 and 10. So I'm going to just stick there. But I'll kind of review how to do that. So we're going to hit tab, right? And we're going to go to control, divide. And then we're going to plug in sine of x over x plus 2. So trig sine of x divided by x plus 2. And the reason we're doing this is we want to plug in the first derivative, and that's what they gave us already. So we're just going to do it just as it is. Now, I do see this is pretty zoomed in. So that's because right now my y values are pretty big. So I'm going to just, to zoom that in, what we can do is go to Windows Zoom, Windows Settings. Now I went from negative 0.5 to 10.5 because I was going from 0 to 10 and I want to be a little bigger and smaller. Now for my y values, if we look at this, we can see that they never go up above 1 or below 1. So what I'm going to do is, since they never go above 1 or below 1, they never even hit 1, I'm going to just zoom in by saying I want my smallest y to be negative 1, and I want my biggest y to be positive 1. And so now this gives me a much nicer graph to look at. And so figuring out what to plug in there, what to type in there, it's just practice. The more you do these, the better you'll start to get at them. So we can see that we have a 0 at 0, but we don't care about that one because it's an endpoint. We already know about it. We only want ones that are inside of our endpoint. So we're going to go to Analyze Graph. We're going to go to 0. We're going to go to the left of the first 0 and to the right of the first 0. 3.14159, that looks like it's pi. Right, then Menu, Analyze Graph, 0. And we have 6.283, that actually looks like it's 2 pi. That kind of makes sense because it's for sine of x, right? Sine of x is at 0, pi. The next one would be 2 pi. So Menu, Analyze Graph, 0. This third one over here, at 9.42. So to me that looks like it's 0, pi, and 2 pi, but if you're not sure, just write them as actual decimals. So 3.1416, 6.2832, and 9.4248. So we're going to go ahead and write those into our number line. And actually, we don't even really have to worry about that too much, honestly, because this is multiple choice. We don't have to write it out. So you could if you want to. I'm just going to put them as pi, 2 pi, and 3 pi. And if you didn't do this, that would actually be okay. I'll kind of show you how to look at it there. But in this first region, right, between 0 and pi, we're positive, right, because it's above the axis. Then in the second, in between these 2 points, it goes negative because we're below the axis. Then it comes up positive again, and it goes negative again. So if we drew this out, we're increasing, decreasing, increasing, and decreasing. So how many relative minimums does it have? It just has one relative minimum. The endpoints don't count. So just one relative minimum. Now, another way to think about this is, where do we have relative minimums? Well, that's when f prime changes from going negative to positive. Right? Well, if we looked on our graph, how many times does this change from negative to positive? It's only once. It's only right here. Right? We said 0 doesn't count because that's where we're starting it. So if this confuses you, you could even, like I said, I like to add a little bit on each side, but if you literally change this from 0 to 10, that would prevent you from worrying about that. We wouldn't have to worry about that left of it. So it only changes one time from negative to positive. Right? It doesn't ask me where, right? It just asks me how many times. Okay, next up, this one is a calculator question, but in this case, we actually don't have to use our calculator. So the derivative, and that's actually kind of common. The derivative g prime of a function is continuous and has exactly 2 zeros. Selected values of g prime are given in the table above. If the domain is the set of all real numbers, then g is decreasing on which of the following intervals. So them telling us that it has exactly 2 zeros is very important, because if they didn't tell us that, we actually couldn't do this question, because we don't know any of the values of the decimals. Like, there could be another 0 somewhere in there, and so it could have gone up to positive and back down to negative somewhere we didn't know about. So I like to draw a number line on these still, right, because we want to know where is it decreasing, right? As soon as I see where is it decreasing, I want to draw a number line for g prime. Then my zeros are at -2 and at +2. And to the left of -2, my y values or my g prime values are positive. Then in between this section, my g prime values are negative. And after 2, my g prime values are positive again. So it's increasing, decreasing, increasing. So g is decreasing for -2 to +2 only. Okay. The second derivative of a function is given by f double prime of x equals x times x minus a times x minus b squared. The graph is shown on the right. For what value of x does the graph have a relative maximum? This question is pretty tricky. So it wants to know where we have a relative maximum. Where f prime has a relative maximum. Not where f has a relative maximum, but where f prime has a relative maximum. So what you may want to do on this is kind of go back to the chart that we had. So we made a chart, quite a while back where we had this guy, right? And so for f to have a relative maximum, that would actually be, when f double prime is 0, that's where f prime would have a critical point, right? Now, it would be a maximum if it changed from positive to negative, right? So that's a little bit tricky, but what we kind of want to think about here is that f double prime being positive matches up with f prime being increasing, right? So this question is tricky, but it's definitely doable. So what we're going to say is kind of that we're connecting f prime with f double prime. So remember, f double prime being positive, that matches up with f prime increasing. Now, of course, it also matches up with f concave up, but this didn't mention anything about f, right? And f double prime being negative, that matches up with f prime decreasing. So if we want to know where does f prime have a maximum, that would be when f prime changes from increasing to decreasing. So that would be when f double prime changes from positive to negative. So where does this change from positive to negative? Here at A, f double prime goes from positive to negative, and that's it. Right at 0, it would be a minimum, and at B, it would be neither. So this would be A only. It's a kind of tricky question to wrap your brain around. Okay, next, if h of x is a twice differentiable function, for h of x is less than 0, then at what values does the graph g of x have a relative maximum, if g prime of x is equal to 9 minus x squared times h of x. Now, what they told us is h of x is less than 0, so it's always negative. So whenever we want to see relative maximum, relative minimum, increasing, decreasing, our first step is going to be to take g prime of x, set it equal to 0. So I can say 9 minus x squared times h of x equals 0. You can use your calculator for this with the solve button, or you can just solve it. So really, we know that basically we can set 9 minus x squared to 0, or we can set h of x equal to 0. Now this, we know never happens because it says it's always less than 0. This, we're going to add x squared to both sides, square root both sides, and we get x equals plus or minus 3. So when we make our number line here, we want to make our number line for g prime. We have negative 3 and we have positive 3. And we're going to plug them in to this line where we had it, kind of most factor. And we know that anytime we plug in for h of x, it's always less than 0. So this is always going to be a negative when we plug in for h of x. So if we plug in negative 4, 9 minus negative 4 squared is like 9 minus 16. That's a negative. Negative times negative is a positive. If I plug in 0, 9 minus 0 is positive. A positive times a negative is negative. Then if I plug in 4, 9 minus 16 again is negative. But we have to multiply by h of x, which is always negative, so we get positive. So where do we have a maximum? Well, we're increasing, decreasing, and then increasing. So there's a maximum at x equals negative 3. Okay, again, some of these multiple choices are tricky to kind of think about, but it's really about practice and repetition. They're definitely hard. The more we do, the better we start to get, and we start to see these patterns of when it asks this, this is what I do. When it asks a different topic, then I change it to do it this way. Next one, a table of values. A table of function values for a twice differentiable function is pictured to the right. Which of the following statements is true if f of x has only one 0 in between negative 3 less than or equal to x less than or equal to 3? So they're saying f of x has only one 0. So that means essentially it's going to be 0 somewhere in between 1 and 3. We don't know where. We don't know if it's 2 or if it's some decimal, but somewhere there it's 0. Now, this is kind of interesting, but they're saying which of these statements is true, and it's kind of like that must be true thinking. And so this is pretty tough, but what we want to really make sure that we're careful about in this case is we need to make sure that we're okay with realizing there can be other options, right? So there can be other options, and essentially it can go kind of up and down. So the first question says f prime of x is less than 0 on the interval between negative 3 and positive 3. And if we look at this, we're going, are y values right? What does f prime of x mean? When f prime of x is less than 0? Well, that means that f of x is decreasing. And this is where it is a little bit tricky, is we don't know what negative 2 is. Negative 2 could have been 12. So it could have gone up to 12 and then it could have gone back down to 8. Like, we don't necessarily know that. So this one doesn't have to be true. Okay? F of x has a 0 between x equals 1 and x equals 3. Well, this one is true by IVT, right? Because if it's differentiable, what does that mean? If it's differentiable, then it had to have been continuous. And IVT says, right, that essentially if we have a positive value at 1 and we have a negative value at negative 13, there would be a 0 in between them. So this one is true. And the third one is f double prime of x is greater than 0 on the interval from negative 3 to positive 3. And so this kind of, that f is double prime 0 would be f is concave up. And so what that kind of means is that means that the rate that f changes is increasing. That's what that means. This is kind of a hard concept, but the rate that f changes, that's f prime, so f prime would be increasing. So if we kind of look at the slopes of this, right, from 10 to 8, this goes down 2, and then it goes over 2. From negative 3 to 1, it goes over 2, so the slope is negative 1, right? Then from 8 to 2, it goes down 6, and it goes again over 2, so the slope is 3. And from 2 to negative 13, it actually goes down 15, and then over 2. So the slopes are kind of 1, and then negative 3, sorry, negative 1, negative 3, and negative 7.5. So the slopes are actually getting smaller and smaller and smaller, not bigger and bigger and bigger. So that would show concave down. But again, we don't know anything in between. So we really can't say anything about 1, and we really can't say anything about 3. Even though it looks like it's decreasing, right, it's going 10 to 8, 8 to 2, 2 to negative 13, we can't say for sure that it's less than 0 on that entire interval, right? Because maybe somewhere in there it would have been positive. So this one would have been 2 only. And that's actually not even an option. So this should have been 2 only. They may have, I don't remember from this exam, or if this was on exam, or if this was just written by another teacher, that the question might have actually marked that as being correct. And so maybe they chose 1 and 2, because these are decreasing. But on the AP exam, we just want to be very careful about anything in between that we don't know about. Right, we don't know what the value at 0 is. It could have gone up to 20 and then come back to 2. And if that's the case, then it wouldn't have been decreasing the whole time. So I think this should have been worded a little bit better. Usually they'll use the word must be true. And that must be true would get rid of number 1. I think maybe because they said which of these are true, maybe they marked number 1 as being correct. But I promise you we'll have it a little bit more clear on our test if we have something like that. So anyways, shoot me a message if you have questions on any of these or on the free responses that we did. And our test will be coming up soon. We are going to have to kind of think about this line of thinking. And then we'll also have to be comfortable, especially with these first 4, about starting to use our calculators.